Hi, so this is our video of the third lab for EC311. We will first show a brief overview of our Verilog code, followed by a demo of our design running, and finally explain the successes and failures of our lab. In our top module, we included a flip-flop that allows us to change our output mechanism from a switch to a button so the user can pick the mode of output. This is initialized here. We had to create this to supplement the top module because a button does not consistently toggle and we couldn't just change the switch to a button in the constraints file. For our input, we have a clock and we will be counting its cycles so we know how much time has passed in the FPGA. The parameter that we initialized oscillates at 25 MHz per 10 milliseconds. We also have an input D, which we will debounce through the code and use for output Q, which we will utilize in our top module. We declared rcount and rstate to store values up to 18 bits. In our always block, we first increase the counter until it's stable for enough time in our first if. If the following else if is executed, this means that the end of the counter is reached and we reset the counter. And the else refers to the idea that the buttons are in the same state and we reset the counter once again. After this always block is the assignment that gives us our output of the register. This allows us to successfully use a push button for our output mechanism. Next, we will be talking about the new relational mode in our ALU. It uses comparison modules that we initialize in the beginning to determine whether it's true or false that A is greater than, less than, or equal to B, with 1 symbolizing true and 0 symbolizing false. This is contingent on what operation the user wants and inputs. This also means that we had to modify our decoder to account for this new mode, and we incorporated another bit of opcode to accommodate for all these different operations as shown on the screen. We also attempted to include a game mode, but this doesn't work and will not be used in our demo. We will further explain and discuss why this doesn't work and is something that we consider as a failure at the end of the video.
Alright, on screen I have a diagram of how the VGA addressable video works. So when H count is between 144 and 784 and V count is between 35 and 515 is when you can address a certain color to the output. And when H count is less than 96 and V count is less than 2, that's when you have H sync and V sync happen. And so in my code, this is what I do. I set H sync to high and V sync to high when H count is less than 96 and V count is less than 2, respectively. And then in my always block, depending on what the color changer is, I set red, green, and blue to high, only within the addressable video range. So if it's outside of that range, it becomes 0, but otherwise it is the value that I want it to be: red, green, blue, or white. Alright, today I will be demoing the FPGA design for Jack Halbarian and for Nicole Kwan. And so let's get started. The way we input stuff on the FPGA is we use the 4 switches starting from the right for the first 4 bits of A, next 4 for the 4 bits of B, and the last 4 for the original 4 bits of opcode. We've also added 1 bit additional to the decoder and the ALU to signify a relational mode. This allows us to check if A is less than B, A is greater than B, or if A is equal to B. So in our case, starting from the right to the left, A is 3, B is 7, and we are in relational mode, and we're in relational mode 0. So relational mode 0 correlates to if A is greater than B. In this case, 3 is not greater than 7, and we can see that because it outputs a 0. However, if we change to if A is less than B by using 1, then it gives us a 1 because 3 is less than 7. And finally, we can check if A is equal to B and change the output, and it'll say 0 because 3 is not equal to 7. We've also changed the output control. So it used to be controlled by a switch down here. Now it's controlled by a button. So when I press the button, it outputs whatever the result is of the ALU. And finally, for our surprise edition, we've added a VGA display. So if I switch the HDMI to the FPGA here, we can see that it starts on blue, but actually it originally starts on white. And then every 5 seconds it's going to switch color. So the next color will be red. And then after that, it will be green. So after green, then it'll be blue, and then after blue, it'll switch back to white. And so, yeah, these are all the new features of our ALU. So the major successes of our design include adding a new mode for our ALU and our decoder. Another big success was getting the output control to be controlled by a button. And finally, the biggest success was getting the VGA display to work, as getting the video range correct for H count and V count correct was difficult, as well as getting the H sync and V sync to be correct was also difficult.
So one of the most notable failures within our lab was the fact that we weren't able to fully implement our linear feedback shift register as a pseudo-random number generator for our game. And so this means that our game wasn't fleshed out to the point where we could get it to work, but we have provided a skeleton of what it could be. So for the linear feedback shift register, we have two versions of it. One where it takes in a seed based on the state of the switches when the FPGA boots up, as well as another that already incorporates feedback logic within it and doesn't take in a seed. And although both of these simulated properly on Vivado, it just didn't work when we tried to put it on FPGA, and we tried using display functions within our top module, and it showed an X, which means that there was just some sort of error. And if we had more time, we would have definitely delved into this and understood why, but for now we just commented all this out. So to summarize what we did for our lab, we changed the output mechanism from a toggle of a switch to a button, modified our ALU by adding a relational mode, modified our decoder by adding additional opcode and instructions, and implemented a VGA display that flashed through different colors. We chose what we did because we believe that these decisions come together cohesively as a lab and build on our understanding of Verilog while also incorporating a new challenge for us. If we had more time, we would definitely expand on our relational mode and fix our game to make it working. And yeah, that's it. Thank you so much for watching.